So my name is Juan Brenes, I work for Nextworks, and today I'll be presenting a presentation about experimenting with NetApps for transport and logistics in 5G testbeds. This is mainly the outcome of a Horizon 2020 funded project by Vital 5G, which aims to facilitate the design, development, and benchmarking of transport and logistics oriented services on top of 5G enabled infrastructures. I structured the presentation as follows. First, I will briefly introduce the project just to be able to fundament which are the architectural decisions we take, and so that you are able to understand the different concepts that I need to explain. Then I will cover some of the Vital 5G main concepts, which are the NetApp definition, the vertical service, and the experiment concept. And then at the end, I will show how we integrate OSM inside the Vital 5G architecture, explaining how we integrated OSM in the different phases of the project, of the service management, which are the service design, the service lifecycle management, and the service experimentation. So you should have already seen this picture some time before. This represents mostly a typical deployment, the typical deployment that we see nowadays, where you have the virtualized infrastructure of the operator with different controllers taking care of these different segments of the network, and of course you have the NFV orchestrator where OSM fits in for the organization of the different services. And on top, we usually have one end-to-end service orchestration layer, which takes care of bundling everything together and at the end orchestrate the services that we can run inside an operator network. The problem is that despite the amount of research and the amount of money invested, there are two main shortcomings here as far as I understand. The first one is that even though in the last few years the service design and the service lifecycle management has been greatly improved and eased, it is still not yet too easy to the vertical companies to deploy and design the service to be run on 5G enabled infrastructures. And also, moreover, it is not they are not still aware of which are the performance that they might get from a 5G enabled infrastructure. And the second shortcoming is that, as you know, 5G is not mature enough, at least for some of the kind of services that we may want to offer. It's good enough for MBB kind of services, but for URLC and machine-to-machine communication services, the standards are not yet ready. So the focus of Vital 5G, and mainly this was the purpose of this slide, is to explain that in Vital 5G what we want to target is, first of all, provide an end-to-end service orchestration layer that facilitates the service design and facilitates the service lifecycle management and allows the verticals to get some benchmarking indicators that allow them to understand which are the overall performance they may expect from a real 5G infrastructure. And then we are using production-ready 5G in our test. So we will focus a lot on the upgrades on the testbed facilities to bring in the latest state-of-the-art developments in terms of 5G. I will then explain how we are going to fit OSM in all this scenario. Just to summarize the value proposition of Vital 5G, so mainly the activities we are performing inside the project to achieve these objectives, we will deliver a Vital 5G platform, which is composed by a service portal and an open online repository. This mainly enables verticals to design the service in an easier manner and compose some 5G enabled network applications that I will explain in the following slides. And then to facilitate the lifecycle management of these services on top of the 5G infrastructure for our testbed, and automatically and gather benchmarking and monitoring information in an automated manner, so that they can so that verticals can confirm if the KPIs that they could expect can be achieved using 5G technologies or not. Then we have 3 facilities that we use for deploying our services. We have one in the port of Antwerp, one in the Danube River, and in Athens. They mostly focus on different services targeting transport and logistics services. So they focus on different aspects and different business scenarios for transport and logistics use cases. We have 3 main use cases that target to verify that our value proposition has been achieved, and that we can successfully, gather the monitoring metrics and that the overall services offered by the platform can achieve the expected results. And we intend to open our platform so that third-party experimenters can also, on the one side, use the NetApps that have been, some of the NetApps that have been produced in the project, but also to deploy their own NetApps as part of services and gather and perform some testing and benchmarking. This is on the right. You see the conceptual architecture of Vital 5G, which contains the Vital 5G platform on the top, and then the 3 testbeds that I mentioned before. The Vital 5G platform is mainly composed by 2 main blocks: the OpenLNR repository and the service platform on the Vital 5G portal. So in the OpenLNR repository is where we offer the programmable APIs to be able to onboard to onboard NetApps, which are the network applications I will explain in a bit, and to see which are the network applications that have already been onboarded, compose services, design services, and we have some access control mechanisms that allow to regulate the different access to the resources that we have in the catalog. And this OpenLNR repository is of course integrated with the NFVOs and OSM and the OSM deployments available in the different testbeds, because whenever we onboard these NetApps, there might be orchestration descriptors associated with these packages, and so therefore we also take care of onboarding, and we have onboarding capabilities on the testbed. The aim of this OpenLNR repository is to be able to share NetApps that are available in our catalog that we developed, and also to be able to onboard new ones if the third-party experiment is required to do so. I will cover this onboarding phase later on in my slides. Then on the other side, we have the service portal, which is the functional block that facilitates the overall service lifecycle management. So it will interact with OSM for the instantiation of the network services associated with our NetApps and with our vertical services. It has some smart capabilities in the sense that it also includes some modules to be able to, based on the monitoring information available and the benchmarks obtained during the experimentation, it is able to smartly allocate the resources on top of the VNFs, on top of the resources available. And this service portal also allows to automatically start collecting monitoring information and generate reports that convey how if the service has achieved the overall expected KPIs, or and produce reports overall benchmarking, the overall assessment, the overall performance assessment of the service instance. Both of these blocks interact with OSM, as I mentioned before. In this case, the service portal interacts with OSM for the instantiation of the service, interacts with the testbed infrastructure to either retrieve the available 5G slices to be attached to our services. It also interacts with OSM for the configuration of the monitoring data sources that we will need to be able to extract the required information included in our experiments. A little bit about the concept of a networked application. The idea here is not only that we will have BNF, but the idea is to extend this concept so that we can include information to make these applications 5G. Okay, so the idea here of a networked application is that we extend the concept of a BNF to be able to include some parameters regarding the profile, the traffic profile that is required by this virtual network function. For instance, including the data rates that are required from the 5G network, the overall expected latency. This is depending on the type of slice that we may want to target. For instance, MBB, we will focus on the data rates, on the uplink and downlink data rates, and for URLC, we focus on the latencies expected in each of the segments, and so on. And as you will see, we'll also add some other metadata to the BNF to make it easier to be composed in service change, so that the NetApps that we onboard in our catalogs can be composed by third-party experimenters to form part of their services and facilitate this way the overall service design just by having NetApps already available in the catalog. This is a graphical representation of what we consider is a NetApp. As you see here on the top, on the left, the NetApp package includes the BNF package, the typical BNF package from OSM and as analyzed by ETSI. And we added something that we call the NetApp blueprint that includes all this extra information that we need to make applications 5G ready. So in the NetApp package, we have the usual VMS, VMAX, VNF descriptors, and so on, probably also VNF licenses. And in the NetApp blueprint, we added the information that we required, as I said, to correctly attach this to a 5G network and make it easier to be composed in more complex service chains. Specifically, we added 5G slice profile specification associated with the different endpoints that we describe inside the NetApp. So mainly a NetApp can contain different endpoints that describe how this NetApp interacts with the external world, let's say. And in here, we can specify which are the service profile parameters that we need to in order to connect to the 5G network. This information will be then used by the service portal to select and probably instantiate the 5G slice that we need to be attached to the service. We also have the capability of specifying which are the infrastructure metrics that we may want to collect from infrastructure once this NetApp is deployed. For instance, we may want to gather CPU monitoring data for some of the components of the NetApp. We may want to gather disk usage for some specific NetApps, and so on and so forth. So that we can gather computing related metrics from, or we can describe which are the computing metrics that we want to gather when this NetApp is instantiated. We also provided here the capability to extract data rate monitoring data, latency monitoring data. This could also, all this can be perfectly and also already included inside this NetApp blueprint metadata. And we also provide the capability to, or we also included application metrics as part of the NetApp blueprint specification. These application metrics mainly refer to the metrics that we want to collect specifically from the service. So it's not something we can extract from the infrastructure. It's something that we need to extract from either the containers or the VNFs that compose the service. And also we have some parameters that allow to better understand how this service is deployed and which kind of service is offered. We have the name, the description, and the atomic components that actually represent the functional blocks of the NetApp. We also have an interface specification parameter, which allow us to specify the kind of interfaces as exposed by the NetApp, so that we can easily, or that we can provide more information if someone wants to use this NetApp as part of their own service. Here you can provide the Open API specification, you can provide a document attached to the NetApp so that this is easier to integrate. This is a graphical representation of what an actual NetApp may look like when deployed in a 5G infrastructure. This is an IoT event manager example, so an IoT management platform. On the left, you see actually the radio access network with some local field and IoT supervisor that gets monitoring data from the sensors and actuators that are deployed at the premises. And you have the 5G network with a pre-provisioned slice that was selected using the mobile traffic characteristics that we included in the NetApp blueprint, as I said. And here you have the different atomical components of the NetApp with the different connectivity services that glue them together. And you can have interfaces specification for all the different interfaces, either internal or external, that are offered by the NetApp and described inside the NetApp blueprint. And there are two main concepts inside 5G are the vertical service blueprints and experiment blueprints. On the one side, the vertical services allow us to attach different NetApps together so that they can be composed to build a chain of services with a higher level of complexity. This is the equivalent with, extends a little bit the concept of the NSD in some sense. It's an equivalent concept, but in terms of composition, let's say. So we have developed a vertical service blueprint which more or less follows the information model that we presented for the NetApp. It allows us to specify the application metrics, infrastructure metrics, the connectivity service that glue the different NetApps together, the required hardware that we need in the field in order for this vertical service to work, the service sequence, and particularly the service sequence and the atomic components determine the NetApps that will be used as part of this service. This is usually on board with the network service descriptor, the typical network service descriptor from OSM, so that we also have the descriptors that we need to orchestrate this vertical service. So vertical service blueprint aim to just facilitate service composition and service management, but we also need the network service descriptor to describe how all this is orchestrated. And the last concept that I wanted to explain is the concept of experiment. Experiment in Vital 5G allows us to automate the execution and validation of tests on top of instances of our services. So they mainly describe the steps that we need to follow when executing one experiment, which are the test scripts, the metrics that we want to gather to validate our experiment, and the KPIs that will be computed, and if we have some KPI thresholds against which the KPIs will be matched automatically to see if they were fulfilled or not. This is the software-oriented architecture that we have in our project. On top, we have a GUI that interacts with the different modules and the different blocks of the software of the Vital 5G platform. On the right, you see we have the OpenLN repository as more or less following the philosophy of the conceptual architecture. We have an experiment catalog, which holds the experiment blueprints. We have the NetApp catalog, which holds the NetApps. We have a service catalog that holds, that stores the vertical service definitions. We have some validator modules that make sure that everything we onboard is properly described and it follows the right format and so on. And we have something which in the future will be able to validate that when we instantiate one NetApp and one vertical service, the licenses associated with those NetApps are fulfilled or not. This Vital 5G Open repository interacts with the orchestrator catalog, so we'll interact with OSM to onboard VNF packages together with the NetApps, as I will explain in the next slides, and then onboard network service descriptors associated with vertical service blueprints. On the other side, we have the portal backend, which also is the representation of the service portal I described before. It will interact with the orchestrator lifecycle with the OSM lifecycle management API to trigger network service instantiation and termination, and basically translating the vertical service request into network service level requests. And it will interact with the monitoring platform of the testbed to be able to configure and retrieve monitoring data related to the infrastructure, so mainly computing, network infrastructure, network data sources also, and information that we may want to gather from the VNF and the containers themselves. This is the representation of the different interfaces that we have, because we decided to follow a unified interface from the platform to interact with the testbeds. So the different models of the platform use a standard and unified interface to interact with the 3 different testbeds with different deployments, and then we use a plugin-based approach to actually interact to customize the request towards the specific testbed. Although for the orchestration, all the 3 testbeds use different versions of OSM. So for the orchestration plugin, this is mainly based. This will be 100% based on an OSM driver. As I was saying, the service catalog and the NetApp catalog use a standard interface to interact with the catalog of the orchestrator on the testbed, and to onboard the VNF packages and to onboard network service descriptors. Then different modules interact with the lifecycle management API or uses the lifecycle management API offered by the testbed to provision the network services associated with the vertical services, and to configure the different VNF in order to execute some scripts and configuring the monitoring data sources that we need. This is how the Vital 5G NetApp package onboarding actually works. Right now, we have already this portal will be available, and it has a wizard that allows us to onboard the blueprint and the VNF package. And when we trigger this, automatically the backend triggers the onboarding into OSM, as you can see here. This is mainly follows this procedure. We trigger the onboarding of this NetApp blueprint through the northbound interface of the backend. This comes bundled all together, the VNF package and the and the NetApp blueprint. The NetApp blueprint is stored internally at the NetApp catalog, and then we forward the onboarding of the VNF package to the orchestration, to a per testbed plugin, which actually translates into the onboarding, into the specific onboarding API implemented by the OSM in the testbed. Then, in terms of service lifecycle management, we don't have the GUI ready yet. We are working on that, but we can trigger the vertical service instantiation. This vertical service instantiation will be translated automatically by the service portal into the network service and deployment flow and instantiation level that needs to be passed to OSM as part of the service instantiation workflow, and it will eventually trigger instantiation OSM. In terms of interface, what it happens is we received an instantiation of a vertical service given with a given desired vertical service parameters and the IMSI-IDs that we may want to attach to this service. The platform will automatically compute the network service descriptor that we need to instantiate, the deployment flavor and instantiation level. Depending on the testbed capabilities, when we trigger this instantiation, the platform will either select a slice, a 5G slice from the ones already pre-provisioned in the testbed, or it can, in some cases, it can also request instantiation given of a specific slice to fulfill, or let's say, considering the traffic profile described in the NetApp. So basically, trigger the instantiation of a slice, specifying the uplink and downlink data rate, the expected latency, and so on and so forth. In this case, what we do is attach, we request, when we forward the instantiation request towards OSM, we select which are the beam networks that this service should be attached to in order to be stitched together to be stitched to the 5G slice that has been provisioned or has been already or was pre-provisioned before the service instantiation. And we pass the testbed where we want this service to be run. And this per testbed plugin takes care of translating this into the OSM specific API that we need to use to interact with the OSM in that testbed. There are some things that we are still working on. Because actually, when we instantiate the service, we also need to allocate the monitoring metrics, the monitoring data sources that we want to. We need to configure the monitoring data sources that we need in order to gather the monitoring information described in the NetApp and in the vertical service. Basically, this means that this service testing, this vertical service lifecycle management model will interact with the monitoring model of the platform, passing information about the metric ID that we want to collect, the name, the type, the component ID which this metric is associated to, which could be either a VNF probably or a container or something in infrastructure, and the network service instance that we allocated in OSM. We are actually working on defining a unified interface that will allow us to automatically go and configure OSM in order to extract either the computing metrics that we need to gather and configure the different DNF of the network service to automatically push monitoring information to a centralized bus that is used by our platform in order to collect the monitoring information. in terms, once we have a vertical service instance up and running and already collecting monitoring information, the user may want to execute a test to see if the KPIs were fulfilled or not. So given that we have already onboarded our experiment blueprint describing the kind of metrics that we want to collect, the test scripts, and the KPIs, the KPI thresholds that we want to match against, and a user may come and execute or run an instance of an experiment on top of a vertical service instance. So whenever someone wants to run, they just need to pass the experiment parameters and the vertical service instance to which this, on top of which this experiment should be run. And the service testing experiment manager will actually use OSM primitives to, first of all, configure the DNF with experiment parameters that we have, that the user has described, and also to execute scripts in an automated manner. We are still, nevertheless, working on how this will actually work. And that was all from my side. I don't know if you have any doubts, any comments, and maybe I went too fast.
Thank you. I don't see any question in the chat, so maybe we can move on because we run a little bit over time.
I have a question.
Yes.
Okay, very quickly then.
Yeah, it will be just quickly. Yeah. Yeah, thank you for this nice presentation. So you was referring to the KPIs, the key performance indicators that you collect.
Yes.
So what are the KPIs that you are collecting? Are these like performance and latency KPIs? And are you collecting them from all test beds? Yeah, just.
Yes, okay. Most of the times we refer to performance KPIs. Okay, so as far as we have seen, and also taking into account some previous experience we have in other projects called 5G, most of the times verticals are interested in knowing how fast the service can respond and the kind of how many actual effective bandwidth they can allocate on top of the 5G slices. Okay, so we mainly target network KPIs. Okay, this doesn't in any case prevent from collecting other kinds of KPIs. For instance, if you want to measure the amount of alarms that your service, the IoT platform was able to collect and to raise given in a certain deployment scenario, you can do that with our testing facilities, because we allow to describe different kind of metrics and refer to those metrics. Actually, when you the KPI specification is a formula combining the different metrics together. So it's very flexible.